Hello, everyone. It's 5 p.m. local time, and we shall begin. A very warm welcome to everyone. We are really excited to welcome all of you here to what promises to be a fantastic session. It's a packed house today. We have a pretty diverse group of attendees from about 27 different countries, the last I checked. We also have a few early morning risers from US and a couple from Canada as well. Good morning to you all as well. My name is Anand Taparia. I take care of marketing here at Utunga. It is indeed our privilege to co-host this webinar with the FDT group led by Glenn Schulz, who is of course also the speaker for today. The focus of today's webinar is FDT 3.0, and Glenn will take us through the state of the industry, the advancements in FDT specification, key features, toolkits, and solution development with FDT 3.0, among other insights. Before we get started, a quick introduction of Utunga. Next slide, please. Okay, while we wait for the, sure, great. Utunga is a product engineering and an industrial solutions company partnering closely with OEMs in the industrial world to build products and solutions from concept all the way through the life cycle of the product. Be it enabling field devices to communicate with other systems in an interoperable manner, or adding a digital layer to purely mechanical or non-digital devices, or building configuration, calibration, diagnostic software, or even highly sophisticated software and hardware systems. We leverage our rich pool of engineers to co-build products and solutions for our customers. We offer services in application development, embedded services, IIoT, and verification and validation. Our services are targeted to OEMs and end industries in process, factory, and power domains. We work closely with various standards bodies in the industrial world. Our association with these consortiums and also the FDT group is rooted in our commitment to help OEMs build interoperable industrial applications. Next slide, please. And I would now like to introduce our speaker for today. Largely to the community present here today, Glenn needs no introduction. Allow me to still introduce Glenn. By the way, Glenn and his team of Maggie and Katie are in US right now, awake this very early hour. Glenn has been serving as the managing director of FDT Group since July of 2009. Before joining FDT Group, Glenn was the managing director and vice president of engineering at Dorner. And before that, for 13 years at Rockwell Automation, with responsibilities that included the process industry asset management business. Glenn has been instrumental in establishing the legal non-profit structure of the FDT Group that culminated with incorporation in Belgium. Glenn has numerous design credits, articles, and patents in topics such as real-time information-based material handling, industrial and process control security, asset management, cryptography, RF data transmission, very low power intelligent sensing technologies, electronic operator interface, and root cause analysis. Before I hand over to Glenn, just a few quick housekeeping points. The duration of the webinar is 60 minutes, which includes a demo video as well. We will utilize the last 15 minutes for questions from you. You can type in your question anytime using the questions feature on your screen. Or if you prefer to ask verbally, you can do so in the last 15 minutes. Simply press the raise hand button and Katie will unmute you to ask your question. Our request is if you could keep your questions crisp. The slides of this presentation and a link of the recording of this webinar will be emailed to everyone post the webinar. With that, over to you, Glenn.
Thank you, Anand. I appreciate that kind introduction. So here's our agenda then for today's conference. We'll talk a little bit about the state of the industry. We'll dive into what the digital transformation is with the new FDT3 or FITS standard, as it's often known. We'll give you some ideas as how you develop products with the FDT3 standard. We'll hit on some of the business benefits, both from an end user and from a manufacturer's perspective. We'll tell you what we have for deliverables in the way of the FDT3 standard. Then we'll go through a very nice demo that's been provided by Flowserve, who's been very active in the FDT3 standards development. And then, as Anand mentioned, we'll leave plenty of time at the end for questions and answers, both from myself and from the Utunga staff. So let's get into it a bit here and talk about the state of the industry. So the modern industrial manufacturing environment is certainly under change. It comes to us in a variety of ways with Industry 4.0, IIoT type initiatives and so on. But when you dive into it, what you see are some common tenets. One is open integration, where people are looking for a standardized way to integrate a variety of devices and products into a single solution. We're clearly seeing the move towards a more data-centric type environment. So while in the past we might have focused more on the control aspects, now we see that integrating data into higher end systems, making data more widely available across the enterprise are certainly key features of the new environment. Mobility has certainly come along as the devices have supported it. So the ability to access a facility and information and statuses and so on from a tablet or a phone, no matter where you might be in the world. And similarly, remote access, and I think the whole COVID situation has certainly brought a spotlight to that situation where people might need to remotely access facilities where in the past they had counted on being physically present. Now they need to access that facility remotely to keep it running, to keep it optimized. And at the same time, we're seeing the need for flexible architectures. So the idea of scalability, so that as product demands scale up and down, the architectures can scale with it as well. Agility and the ability to repurpose production assets for other tasks. Certainly the whole topic of security is on everybody's lips, and we're going to talk a fair amount about security here as well today. And then compatibility throughout that architecture so that we really do have that agility without any undue restrictions. So today, we think primarily as of devices within the manufacturing facility as objects. And the FDT standard has certainly furthered that notion. But with the release of the FITS standard, we're going to see a transition from more virtualization of that perspective, where the device really appears more like an app on the tablet, smartphone, notebook computer, however you're accessing the architecture. So it really is a paradigm change, and this is enabled both by the remote capabilities, the data-centric capabilities, and the mobility capabilities that we've built into FDT3. And we'll dive into all of those as we get a little bit further into the session today. And one thing that FDT has always been known for, and we continue that heritage in our new FDT3 standard, is that we're widely recognized by all the industry standards organizations, IEC, from a broad international perspective, ISA, ANSI from America's perspective, and in China, we're also a GBT standard, which covers all the major standards bodies that end users have asked that we ensure that we have garnered their approval of the standard. And then likewise, all of the networks that are out there in the industry, and probably, as always, a continuing growth in those networks. The FDT Group continues to support all of the common networks out there in the industry, and really even networks that we don't see on this slide, in that many of the leading vendors have legacy networks that they need to support, or even proprietary service level networks, and all of those are directly integrated into the FDT standard. And as we see more standards emerging, such as the discussions going on with the OPC Foundation for a potential new industrial network, we continue to stay on top of those and work with those associations so that they're easily integrated into the FDT standard as well. So a little bit about the scope of what we'd like to talk about then today for empowering the intelligent enterprise. We'll cover the area of security. You can hardly talk about a flexible, agile architecture anymore without immediately asking, so what are the security elements that protect that environment no matter how it's deployed? We'll talk about the standardization that we've driven into this new standard, both bringing forward our legacy as well as some new concepts to expand the standard. Probably one of the hallmark features that are often talked about with this new standard is the fact that you no longer need essentially what was a Microsoft desktop in most cases to access to the FDT system, but you can now do it with any standard web browser. We've also spent a fair amount of time on the standard to make sure that we enable the information-driven architecture that so many people are striving to attain in their facilities. We've done a direct integration with OPC UA and some other techniques to make that available. And the fact that the architecture is service-oriented and expandable both by the end user and by the vendor community. So we didn't develop the new FDT standard in a vacuum. We spent quite a bit of time out in the field talking with large end users, talking with the vendors in the industry to understand what was changing, what was on the horizon, what types of things should we look at to support in the new FDT3 standard. And we did that through use cases. So for instance, on the mobility side, we did extensive industry survey that you might have participated in a few years ago. We visited large facilities to understand some of their unique issues and how that might transition to the broader marketplace. So we've got the idea of secure mobile device management that came out of those use cases. Improving the workflow for plant workers. Don't impose particular workflows on them, but have an architecture that allows for flexible workflows to enhance their productivity. And then generally enhance maintenance efficiency. I think our industry for years, if not for decades, has had a focus on how can we make maintenance more effective. In this new FDT3 standard certainly has use cases that address that. From a security perspective, we adopted a secure by design use case. It is architected to go literally from the sensor to the cloud to the end user. And we also recognize that there are many end users that are in a very secure environment, and we see this typically in the petrochem industry, but it does exist in others, where they won't even allow their control system to have any connectivity to the internet whatsoever, and those are so-called air-gapped solutions. So we took use cases for these air-gapped type installations and incorporated that into the capabilities of the FDT3 standard. Then probably one of the most exciting things from an end user perspective, and it certainly helps our vendor community as well, is our new FDT Hub. This is a single repository for all certified DTMs. They all reside in this repository, and they're available online through the web so that you can get direct access to the DTMs that you need in a one-stop environment, or we can also offer it offline for those companies that need air-gapped support but want the features of the FDT Hub. And we'll dive into that hub a little bit later to talk about some of the features there and how exactly that works. So a little bit about the digital transformation with the new FDT3 standard. This is a graphic that you'll see used repeatedly throughout our documentation and throughout this presentation that gives you an overview of how the standard works from our new server perspective, our FDT IIoT server. And you see that server in the center of this diagram. That large blue rectangular field has all the components within the server, and we'll talk about some of those aspects as we go through this presentation. But you can see we have connectivity to remote facilities, regardless of whether they're process or hybrid or discrete manufacturing facilities. On the upper right of that diagram, you see the connectivity to through a variety of methods, whether it be browsers, through wireless devices, desktop applications that are running metrics, an OPC UA client on some device, or direct integration to MES and ERP type applications. And then on the left side of the diagram, you see the FDT Hub, and we'll come back to that a little bit later, where all the DTMs are securely stored so that the server can get direct access to the DTMs that are needed to support the various facilities that are connected to that server. So that's a real quick overview of that diagram. To talk about some of the specific server features, the concept with the new FDT architecture for FDT3 is that you can have a single server environment to support an entire enterprise. But what's very interesting about it is not only is it enterprise class, it's highly scalable. So this server can be deployed in a very basic fashion on something like a skid, where perhaps a vendor that's delivering a specific functionality like a bottling line to a brewery, for example, where they have metrics that they have to meet in terms of availability, throughput, reliability, and so on. They can embed a small FDT server right on that skid, and yet that very same code base scales to a full-blown cloud-based solution that can support an entire enterprise with hundreds of thousands of devices connected. The security is built into the FDT server. All points of ingress and egress within the server are completely secured, and we'll talk about that in a little bit. Another interesting feature of this is fully platform independent. So we've removed all dependencies on Microsoft platforms, and not only for the server, but for any clients that connect are completely platform independent. And by this, we mean that you can literally take the same code and install it in a Microsoft platform, a Linux platform, a Unix platform, or an Apple platform, and run the same code in any one of those operating systems. Because of the data-centric nature of where we're going with these type of architectures, we've embedded a native OPC UA server, so it's completely wired and ready to go within the FDT server. It's not an option. We provide it directly as part of the server, and it knows how to automatically get all of the data from all of the DTMs for all of the devices installed in that facility, as well as all of the network health data of that facility. We also have an embedded web server within the FDT server. This is how the clients would access it from a browser perspective. So you can hit it with any major web browser, and you'll be able to do all of the features plus a bunch more that you were able to do with the older FDT standards. You're no longer bound to a desktop application. Everything is accessible through a web browser. We have universal device integration. This is the hallmark of the FDT standard, and it carries forward to the FDT server. So simply having the DTMs available immediately make those devices directly integrated into the FDT server and available remotely, mobile, or direct access from the server. And the server itself is a common component. For those not familiar with that term, we use the term common components for our developer toolkits. So any vendor that would like to develop tools related to the FDT3 standard can use our common component developer toolkits, and the server itself is a common component. As we supply it, it is essentially ready to go. But as you see in the diagram in the lower left of the center core of the server, you have a custom server value add area. This is where a vendor can take this server and wrap additional features into the server. And an example of this might be a large DCS vendor can take this server and integrate it directly to the DCS environment to provide all of their asset management functionality, and yet have it use the same project structure and so on that the DCS environment would be. But it'll work equally well in a standalone environment, so it can be deployed as it is as a common component. From an open integration perspective, we've spent a lot of time making sure that there's wide variety of integration methods based on what end users are asking for in terms of integrating data throughout their enterprise. So we've got the FDT server for distributed architecture. So you could simply put a server in for each facility within a given customer, and that would be a perfectly acceptable solution. But it's also architected so that the server can handle multiple facilities or the entire enterprise. We still maintain an FDT desktop version, so the same standard is deployable in the classic desktop environment for single user architectures. It doesn't necessarily, though, have to be on a Microsoft-based desktop. It could be on an Apple-based desktop, for example. But we maintain this for the single user architecture, so this is not browser-based, but it does allow you to deploy it in a simple, lightweight fashion. This is popular for maintenance folks, for instrument shops, and so on that just need a lightweight solution that they can take with them wherever they are. We have FDT DTMs, and these support the devices. So this is the driver for a particular device if you're not familiar with our standard. So if somebody, for instance, is making AC drive, in order to integrate that AC drive into the FDT standard, they would create what we call a DTM for that drive, which is the software representation of that AC drive. And you can then configure and examine that AC drive, whether it's online or offline, through that DTM. The DTM is also the device or the method that makes the data available to the rest of the enterprise from that device. From a deployment perspective, as I said, this thing is scalable from SCID to cloud. And so we're talking about being able to put it in a very small Unix platform or Linux platform, for example. Perhaps not quite, but you can think of something like a Raspberry Pi type environment supporting a handful of devices on a SCID, but you can scale it all the way up to a full-blown Linux environment in the cloud to serve an entire enterprise, and again, all with the same code base. You can place this anywhere in the architecture as well. So while we often talk about cloud, because that's probably the most advanced deployment version and the most scalable deployment version, you could just as well deploy this on premise. So if you have an IT department that has a server farm where this would be located on that premise for a particular facility, or you could push it out to the edge. And this is certainly becoming a more talked about deployment architecture as the IT, OT organizations collaborate on advanced control options. And the FDT3 standard does allow an edge deployment scenario. We have this cross-platform functionality, so not only can you deploy the components on any operating system, it'll also cross-function. So you could have, for example, Apple tablets that you are using a browser on those tablets to access a server that's running on a Linux platform. And we have full sensor to cloud integration through this methodology. So you have a direct maintenance and optimization data path, and this is available anywhere in the enterprise. We have support for all of the IT networks and OT protocols. So while we typically think of the FDT server as directly integrated into the operations side of things, it can just as well bridge across to the IT networks where perhaps the OPC UA data that's being served up would move across the enterprise. And we also have backwards compatibility built into this standard. So the FDT desktop environment is fully backwards compatible. You can take all of your old DTMs if you have an existing deployment, install the new FDT3 desktop version, and you can leverage all of those old DTMs on your desktop environment. And we also have full FDI device package integration within that FDT desktop environment using standard FDI DTM. And so if you have some device packages that you'd like to integrate, you're free to do that as well. So let's talk about some of the key features of this new FDT server, since that's one of the major new enhancements to the standard. So we have this integrated web server within the FDT server. It leverages a full browser-based environment. So this includes both the client access of the DTM, and it also includes the access of the server. So things like the project structure and so on that traditionally came from what we called the FDT frame are available through that web browser interface. This completely modernizes field device management, so we completely divorce ourselves of operating system independence, and it gives us the ability to remotely access or access from a mobile environment all of the information that's available from the FDT server. This also transforms the idea of how you can do remote asset management. And again, certainly in this COVID environment, this has come front and center. The ability that you could manage your assets from the comfort of your home office, as long as the security settings allow you to do that, is really a step forward in terms of how the industry can address asset management. We have the embedded OPC UA server. Any client can access that, any OPC-based client, and you can download free clients where you can simply browse through the OPC structure, and you could find all of the devices that the FDT server is connected to, and you could look at all the parameters of those devices through that OPC connection. So this completely integrates IT and OT real-time data. You're probably aware that some of the operating systems, MES, ERP, already accept OPC UA data. This will allow it to work across the enterprise. And you can, from an end user perspective, use this OPC UA data as well. So if you'd like to have custom dashboards, management reports that are kicked out from OPC UA data, that's all possible with this embedded OPC UA server. No additional work is needed on your part to get access to the data. And you've heard probably that OPC UA has recently released the pub sub capabilities, and the FDT server will handle the OPC UA pub sub standard as well, publish and subscribe, which helps to, instead of having to pull the server from a client perspective, it'll inform you when data or other conditions have changed as you've set it under the pub sub environment. End-to-end security is a key feature of the FDT server. So we didn't go and invent some new security protocols. We surveyed what were well-accepted protocols and what the end user community was looking for in terms of a robust security architecture. So we've chosen to use TLS encrypted communications. So every communication with a client, whether it's a browser or OPC and so on, uses TLS, they're fully encrypted communications. The server itself has a 509(b)(3) certificate for authentication. You might think of this in the same way as when you go to access your bank site or you're doing a credit card transaction online. We're all conditioned to look up at the browser bar and be sure that this is a HTTPS website and that it is associated with the company that we think we're talking with. We do that in our browser environment. It's TLS that actually does that work in the HTTPS environment. So we're using that same infrastructure with the same types of certificates. But what's interesting is we can also turn that around and install the 509(b)(3) certificate on the clients to ensure that only authorized clients can even access the server to provide the ultimate in security. Of course, we maintain our role-based access control that we've always had within our architecture. So when users log in, we know what their role is and their access to DTMs, information, ability to change parameters, and so on are all gated by that role-based security. And then, of course, our industry is moving towards more on-the-wire security for the protocols themselves. These are activities within the various communication foundations. And probably the one that is most talked about is SIP security from the ODVA Association. That one is published and on the marketplace, and you've seen probably our press releases where we're working directly with ODVA to integrate their protocol into the new FDT3 standard. So one of the new features, completely new features of the FIT standard is this FDT hub, the DTM repository. And I always say that this was one of the things that got talked about the most in terms of a need within the end user community when I would travel to the various end user conferences around the world. So it's really driven by that end user request for simplicity. Make the DTMs all accessible from a single location so that you don't have to visit hundreds of websites to collect the DTMs that you need. But we've done some clever things with this to make it even more than what people were thinking of as they talked about this. So it's a cloud-based solution. The majority of users would access this through the internet with a cloud server that we maintain as the FDT group, but we can offer it as an on-site server, particularly for those customers who have an air-gapped environment and need the ultimate in security. Any certified FITS DTM is located in that FDT hub and available to end users. It's stored there and managed there by the vendors. The vendors can still offer their DTMs through their own website. There's no restrictions on that. This simply provides a single location where end users can look for those DTMs. Their server, the way this works is the FDT server talks directly to the FDT hub. So it's a server-to-server communications. You don't, as an end user, have to go browsing on the FDT hub and finding the DTMs you need and putting them in a shopping basket or something like that. What happens is when the FDT server determines that a new device has been connected to the network and needs to be configured, if it does not have the DTM in its local catalog for that device, it'll automatically go up to the FDT hub, get the DTM, bring it down to the server, and install it as part of the project structure. And this is all transparent to the end user. So it'll be as if the DTM simply becomes immediately available on the FDT server. For those networks that have automatic device discovery, so that when you plug a device into the network, it has a methodology to alert the network that a new device is there, the FDT hub feature will support that as well. So as soon as the device is discovered, if the DTM is not already locally installed in that server, the server will reach out to the FDT hub through a secured connection and get that DTM in support of that device. And I should say these DTMs are often thought of as device DTMs, but they can also be COM DTMs, which are the network protocol DTMs. It could be a gateway DTM and so on. They'll all be up there in the hub. The transfer mechanism and the inquiry mechanism between the server and the hub also uses the TLS security procedures I mentioned earlier. So both servers need to have an appropriate 509 certificate installed. The communications are completely encrypted, and so that the DTM is securely transferred, and it is also digitally signed so that when the server receives its copy, it can confirm that the DTM has not been altered since it's left the vendor or been certified by the FDT group. So let's talk a little bit about how you develop products with the FDT3 environment. So we have the FDT common components. These are developer toolkits for the various aspects of the FDT standard. So the idea here is that we can really create an ecosystem of IIoT ready solutions through a wide base of vendors. These are platform independent tool sets. So while you might choose to develop your product on a Microsoft platform, for example, the resulting components that come out of these toolkits are platform independent, but you can also just as well develop your products on a Linux platform if you prefer to do that, for example. Out-of-box ready components are the FDT server. We have that as a common component, and as I mentioned, a vendor can take that, compile it without changing it, and they'll have a functional FDT server with the features that I've described earlier. They can also take that server, add additional features to it, enhance it, unique value add for that particular vendor as well. We have a FDT desktop common component. Again, this is the traditional single user desktop environment, but it is now platform independent as well. And then if you're developing DTMs to support devices in the architecture, we have the FDT DTM common components that allow you to easily build a DTM without having to learn all the nuances of the standard, because that's all integrated into the common component, and you can focus on the value add of your DTM. The OPC UA integration is automatically enabled in this architecture. So when the server is delivered to the vendor, it's already working with OPC UA. There's nothing that they have to do. In all DTMs, because they follow the FDT standard and are certified to the FDT standard, automatically make their data available through that OPC UA integration. And it requires no additional work on the part of the vendor offering that FDT DTM. That's also auto-enabled. This is a completely modern develop environment. So the user interface is now web UI type user interface. So we leverage HTML5 in JavaScript for the whole user interface aspect of the standard. The nice thing about this is that There's actually more developers now for HTML5 and JavaScript than there were for the legacy Microsoft type user interfaces. So you suddenly have a much broader pool of skilled developers that can develop using these toolkits in this modern environment. This is a little graphic to show you how FDT DTM development works. So on the top, we have a common component that becomes part of the DTM. And here they're building a DTM for a device. We can have device DTMs that are made for a specific device or a group of devices in a family, say a family of AC drives, for example. We can also have DTMs that are interpreter type DTMs where they'll process some other device description like a DD file or an IO-link DD file, for example, and then that DTM works for all of those devices within that protocol. Or we can have a universal DTM that processes certain known features of a particular class of devices and makes those available to the end user. Going along the lower track there, you see the common components where we'll have gateway and communication type DTMs that enable the protocols and networks that the server supports. Whatever the DTMs that's being developed, they all then go through a tool that the FDT has created to make sure that they comply with the critical requirements of the FDT standard. That tool is called a DTM inspector. Once that DTM successfully passes the test requirements of a DTM inspector that's being operated at an independent test laboratory, that test laboratory will inform the FDT Group Certification Office that that DTM has passed the DTM inspector test, at which time they will receive a digital certificate from the FDT Group. We will digitally countersign their approved DTM, and then it'll automatically be placed up into the FDT hub and made available for any server that needs that DTM, as I described before. From a FDT server development perspective, it's pretty straightforward. The server itself is pretty complete as we deliver it, as we've talked about before. But there is opportunity for value add by that vendor to integrate it, to enhance it, to add new features to it. But we'll always have the ability to integrate with the browsers, with OPC UA clients, and with ERP MES type applications. So back to this graphic, I think now you can get the bigger picture of how the FDT server works and how central it is to the new FDT3 standard, whether it's deployed locally at the edge of an enterprise or in a cloud. The server is all the same server. It scales to those different environments. The FDT hub is there, whether it's through the internet or through a private protected connection for those air-gapped solutions. And a server can connect to any type of facility, any type of automation, whether that be local to the server or whether it gets access through a VPN or internet type connections to those remote facilities. Let's just briefly talk about some of the business benefits then that come from the FDT3 standard. From an end user perspective, this fully enables secure remote access of all functions. So certainly what the end user community has asked for and what's coming front and center in the last year is fully enabled with the FDT3 standard. It seamlessly integrates all of the industrial networks into one project view. So you don't even have an awareness that those devices are on different networks or that they're, to get to those devices, you need to pass through various gateways. From an end user perspective, they see the end device, they click on it, and all the network business is handled automatically by the FDT server. Highly scalable, we've said this before, but from SCID to enterprise. And this was one of the things that we have been asked to do by our vendor community because they see a wide variety of deployment scenarios. and we've met that requirement fully. You can securely access this from across the enterprise, and the interesting thing is it requires no PLC or DCS host intervention. The FDT server sits at a peer level with the PLC and DCS, so it is able to talk directly to the end devices, get the data or get the configuration information that's required without having to pass through the PLC or DCS. So no need to do any special programming at those levels. The FDT server can directly access those devices. And we support all the wireless mobile platforms. So while certainly 3G and 4G are here today, 5G is showing up in more and more environments, and it's going to enable a wealth of new features and bandwidth, and the standard fully supports those emerging standards. And in many customers, we hear the conversation of more IT and OT integration, the information technology and operations technology organizations. And we took the architecture to make sure that it facilitated that type of integration for those end users that demand that. We've built this from the ground up with multiple layers of security. And so the end user community can take confidence in that built-in security. We, of course, will continue to ratchet that up as the environments change. You can't stand still in the security market. But we believe from a launch perspective that we've got an excellent architecture from a security perspective. And then finally, to address probably the #1 request from end users, all the certified DTMs will be accessible in the FDT hub, and they're automatically accessed by any server or desktop environment as they're needed. From a system supplier and a device supplier perspective, the new FDT standard really enables new business models because of its scalability and flexibility. This notion of putting asset management directly on a skid as it's shipping out to an end customer is really state of the art for that type of capabilities. We've got a completely secure platform independent architecture. So no matter what the vendor is deploying on or what their end user community requires, they have the flexibility to keep the same code base, keep the same standard, and deploy it as needed. The security helps protect the brand value of system vendors so that nobody wants to have an event associated with their brand, a security event, and the multi-layer security of the FDT standard helps towards that goal. Our platform independent OPC UA server is pre-wired. And so while we've spent the last couple of years working with the OPC Foundation on the mappings for this, now we've taken it to the next level where the vendor community doesn't even need to concern themselves with executing those mappings. They're all pre-wired as part of the common components. And we've taken care to make sure that the environment allows the system supplier to integrate this into larger control or asset management solutions or scale it down for a standalone deployment with their unique value add capabilities. And of course, we've kept the backwards compatibility for the FDT desktop environment so that all of the installed base can continue to move forward in that environment. So what are we delivering on the FDT3 standard? We're talking about doing this today. This isn't a future release discussion. So the standard is immediately downloadable on the FDT website. As we enter the maintenance times for the various international standards, we'll introduce this to the standards organizations to bring it up to date to the new FDT3 standard. The developer tools are all now immediately available. The server, the desktop, and the DTM common components, they are ready to go. The style guide with a responsive design so that as the user interface scales from a small phone to a large tablet to a desktop, the style of the desktop changes in a responsive way. That's also available. And from a communication annex perspective, the heart SIP and Profibus Annex are about ready for release, and we have an IO Link Annex that will release later in 2020, this end of this year. We will be releasing an IO Link Interpreter DTM here later this month. This is a DTM that can support any IO Link device. These are a class of devices where it might not pay to have a custom built DTM for each device. And so we recognize this is a great opportunity to use an interpreter feature and support all IO Link devices with a single DTM. And our new website's completely upgraded to support the new standard. So if you browse the website, you'll find all the new information and aspects of the FDT3 standard integrated throughout the website. And of course, we have a brochure available. That'll be part of the kit that you get as a result of attending the seminar, and it's available on our website as well. Well, I want to get into this FDT3 demo because sometimes PowerPoint seems like PowerPoint magic, and I want to show you that the standard really does work, and there's products that are about to become available using that new standard. And I want to thank Flowserve for making this demo available to us.
Introducing Flowserve's demo of the new FDT3 specification capabilities, utilizing the FitServer OPC UA service and web server. In conjunction with the FDT group, and with support from many member companies associated with the FDT group, this community has developed the new specifications for improved remote connectivity and device monitoring utilizing the new FDT3 technology. In this example, you will see two development prototypes, one of the OPC UA server connectivity to a Flowserve web portal, and the other of the FDT3 DTM utilizing the FITS web server. You can see both servers here in the FITS server management window. The FITS OPC UA server is located in the Springville, Utah Flowserve Valtech site. This server connects to another server located in India, where the data from multiple devices in Utah is accessed through the OPC UA, allowing the user to monitor the devices on-premise or in the cloud. In this example, the FITS OPC UA enables the Flowserve IPS Insight portal to display the monitoring of 10 devices in our Utah plant. With these 10 devices, we have NMERS status updates and dashboard details in a simple yet information-rich interface. The pie chart on the screen shows an example of multiple healthy devices and a single device with a maintenance required alert based on NMERS specifications. When clicking on the blue alert in the pie graphic, we can filter the devices and show the detailed equipment status, including location as originally set up in the software. By clicking on the specified device, we see a detailed breakdown of the status. This data is retrieved from the selected device and connected to the OPC UA server. This is fed live real-time data that allows accelerators to maximize uptime and safety. Not only do the gauges serve up detailed information, there's also a health visual indicator from the device and components critical to the function of it. By separating the valve, positioner, actuator, and control components, a better drill down of function can be represented, helping to quickly isolate information and facilitate required actions. This example shows a warning in yellow that corresponds directly to the active indicator, stating a low friction warning. By selecting the NMER 107 Annunciator panel, a list of summarized alerts and warnings will be displayed. By identifying our low friction warning, indicated by the blue diamond, the user can click on the question mark next to it for further information regarding the implications or warnings of the alert and will display possible solutions. This information can be hosted on-premise at the customer site as an internal support to manage assets and help deploy maintenance with rapid response. Using the read-only connection through the OPC UA of Flowserve's data center, options for 24-hour response and accelerated support can be implemented. This connection will allow a partnership between Flowserve's expertise and the plant personnel to mitigate issues and respond at speeds critical to success. Along with real-time information, the system logs the data in a way that records trends and can be served up in a graphical representation, making data analytics more accessible. Combining this with event history and product information tabs, asset details, including pictures, are placed at your fingertips. Utilizing the FDT FITS architecture, the data from the asset itself can be aggregated on Flowserve's web portal through a seamless OPC UA secured connection, providing a better interaction between device vendors and customers with real-time predictive diagnostics. Another way in which the FDT3 specification can benefit vendors and customers is by performing device commissioning, calibration, running diagnostic signatures, and gathering device information through the FITS server web server and the FDT3 DTM implementation. The web server within the FITS server management tool allows access through a web browser DTM with rich information and graphical representation of the data coming from the device. The user interface of the FDT3 DTM can be customized depending on the needs of the device, as you can see in this demo of the FDT3 DTM. Through the compilation of data within the device, once connected through the DTM, each device can display a dashboard that will serve up details and diagnostics for maximum performance. As shown in this historical ramp signature page, data saved from a previous run signature illustrates the potential for graphical details through charting, trends, and testing in a robust and visual panel. With interactive graphics and detailed data, the new FDT3 DTMs can be viewed in ways that provide simplified yet powerful test details in many different and valuable ways. This includes the opportunity to use a mobile device or tablet to visualize the data at any connected location. The interface will be resized to accommodate the device and present the data in a seamless representation, allowing a connection to the device without any wired or Bluetooth connection, reducing the time it takes to troubleshoot and take action. Here are a few more pages to demonstrate the endless capabilities of utilizing the FDT3 DTM. We would like to thank the FDT Group and member companies for their collaboration and support during development, and look forward to the upcoming full release of our Flowserve FDT3 implementation.
My thanks again to Flowserve for making that video available. So we've reached that time in our conference here for questions and answers. And I see we have some people have typed in some questions. So let's take a few of those. And then if you have questions, you can raise your hand. And I'd be happy to, we'll have our moderator, Katie, open up your mic and you can verbalize your question directly. So if you look at your control panel for the conference, you'll see there's a raise your hand feature. And you can do that. And then you will get the moderator to unmute your mic. So first question I have is, what's the current status of the FDT Hub service? Is it already online? We're just working through that now. We're getting ready to put it online. So I think before we even have certified DTMs in the marketplace, you'll see that's online. We do already on our public website have the application where you can apply to get access to the FDT Hub server. And if you would like to do that in advance of that, you're welcome to do it. We have quite a few applications already that we've received to that effect, and we'd be happy to process yours as well. Next question is FDT3 a competing standard with FDI technology? I wouldn't say it's competing. You know, we own the FDI standard as well, along with the other standards associations that collaborated to create the FDI standard. That standard, you know, really is using or leverages, I should say, the EDDL technology for device description. And so the FDT organization has always provided compatibility on the FDT platform for that, since the FDT platform covers many more networks and devices that are not covered by the FDT platform. We tend to be the overall integration standard. And so you can take those FDI device packages and integrate them into the, FDT system at will and mix them with DTMs to support a wide variety of devices. Let's see, another question is, what does BL stand for on the DTM? Great question. We show that on our literature, and I didn't talk about that. BL is business logic within a DTM, and the other part of the DTM is the user interface. So you have business logic and user interface that are the two main components of a DTM, and it's that user interface that's changed its technology quite a bit with the FDT3 standard, in that we use HTML5 and JavaScript. Another question is, if I have an old FDT frame, will it work with new FDT3 DTMs? Great question. It will not, because of the new technology, but you can directly upgrade that old FDT frame to a newer FDT3 desktop or server, and it'll work with your old DTMs as well as then the new FITS or FDT3 DTM. So a simple upgrade. I think you'll see, as we have seen in the past, that our vendor community will soon offer upgrade paths for all of those installed systems in the marketplace. Next question here is, DTMs are a window component. Now with FDT3, how does the device vendor develop a DTM? So the DTMs are no longer a window component. That was true in previous implementations. Most people implemented the standard in the Windows environment. It wasn't a requirement, but it certainly was the predominant way of deploying it. Under the new FDT3 standard, these are not Windows components. They're platform independent. And so all you have to use is the FDT DTM Common Component Developer Toolkit, and you'll have FDT3 DTMs that are completely platform independent. Kind of a related question to that is, the FDT server is platform independent. How about the DTMs and the FDT frame? So again, the new toolkits for all of those make them completely platform independent. And so if you develop with the new toolkits, that'll come along for free. One question about older DTMs, I take it this is coming from a vendor perspective. Do we need to rewrite all of the existing DTMs to benefit the new FDT3 features? So if you have developed FDT2 DTMs, the prior version of the standard, the primary change that needs to be done is that the user interface has to be transitioned from a Microsoft-centric user interface to the HTML5 and JavaScript. Your business logic and so on can stay intact. And so it's a fairly straightforward migration path. And as I mentioned, there's actually more HTML5 JavaScript developers than there are Windows UI developers. So you actually have a larger pool of developers to call upon for that activity. how do I install FDT3 DTMs? Well, as I mentioned, I think your perspective on that will change. In the past, you had to go find the DTM somewhere, bring it over as a file, then kind of go through a typical Windows install procedure. Well, first we need platform independence, so that Windows install procedure went away, and we now use open package convention standards for distributing the product. And so the install procedure will then occur largely in the background, because when you need a DTM, your desktop or server environment's going to go up to the FDT hub, grab that DTM, and install it for you on your server or desktop environment. And then you decide whether you want to enable that DTM in your project structure. So I think you'll enjoy it because it becomes much more automatic as a result of the new architecture. Question about PA-DIM information model, and will that be part of the OPC UA server? We're actually working with a very large end user right now on that topic. And so I think we can say, yes, it will be available in the future, and we'll base that on the testing that this large end user wishes to do with that environment. But it certainly is a popular topic in the process side of our end user community, and so we look forward to supporting that. Last written question that I see here, if I didn't miss any, is there an offline workflow to the FDT hub defined? And yes, there is, but we need to work with the specific end users in terms of what their security requirements are. So we know how to deploy the server as a standalone within that facility, but issues in terms of how would they like to update the database in that server have to be worked out on a case-by-case basis based on the security requirements of that customer. So I hope that answers the questions, and I'll just ask Katie, do we have anybody with hands raised? We're a little bit past our time here, but if we have a hand raised, we'll take a question. And I don't think so. I think we've handled them all in written questions. So I'll turn it back to Anand. And do you have any final comments from a Utunga perspective? Thanks much for hosting the seminar today.
Yeah, thank you very much. Thank you very much, Glenn, for the fantastic session. And of course, the first-hand quality information on FDT3. Thank you everyone once again for attending the webinar. It has been our privilege to have you attend this webinar. If you do have additional questions or are looking for support on DTM development or migrating from the older FDT spec to this new one, please feel free to reach us anytime at contact@utunga.com. The email ID is contact@utunga.com. One quick announcement before we close. Next month, that is August, on August 6th, Utunga is conducting a webinar on DTM development, where the speaker will take the attendees through the technical aspects of DTM development and also talk about custom DTM and interpreted DTMs. Folks with roles like engineer, product manager, technical leaders would surely benefit from this webinar. Please do share internally with your team members. We will also be sharing the registration links shortly. Now, thank you very much once again on behalf of FDT Group and Utunga. It has been our pleasure. Stay safe. Take care.